Hey guys, welcome back to my channel, and I'm back again with another really interesting coding interview question video. This time guys, we are going to solve question number 933, number of recent calls. But before I start with the video guys, just want to request you that if you have not yet subscribed to my channel, then please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. Let's get started now. So basically guys, the problem statement says that we have got a class called as recent counter, which counts the number of recent requests within a certain time frame, right? So this is the class here, and we have to actually implement this class. And there are two methods in this class. First is the constructor method, that is the initialization method, and the second is the method called as ping. Now this ping method actually takes an argument called as t, whereas this t argument basically represents some time in millisecond, right? So basically this time means it basically means a time at which a new request is entered. Okay, so it adds a new request at time t, and this time t is in milliseconds. Okay, now what happens that when the ping method is called, then we add that new request at a particular time, that time is t, but we also actually return the number of requests that have happened in the past 300 milliseconds. Okay, so basically guys, in the ping method we return t minus 3000 to t. Okay, so let's take this example. Also, it is guaranteed that every time this ping method is called, it is called with a t value that is slightly larger than the previous call. Okay, so let's see this example. Okay, now this is having an input called as recent counter, right? So when the recent counter input is called, it means the class is just initialized. Now the class is initialized, and obviously you see there is null in the output because we are just initializing it. The first time we call ping, we call it with the t value 1, right? That means on the first millisecond a request is added. Now obviously it means that there is only one request in our queue. No other request has been made in the past 3000 milliseconds. So the output is 1. That means the number of requests in the past 3000 milliseconds is 1. Now another request is made at 100 milliseconds, right? Now we have one request at millisecond 1, one request at 100 milliseconds. So the total number of requests in the past 3000 milliseconds is 2. So we return 2. The same thing, now another ping request is made, but this time it is made at time interval 3001, right? So including this request, that means if we include 3001 request and we include all the previous requests, in the past 3000 milliseconds, you will see that a request was made at millisecond 1, 100 and 3001, right? So if I subtract 1, that means the first request, the time of the first request from the time of the last request, the time frame is 3000 milliseconds. So I would still say that all these three requests, millisecond 1, 100 and 3001, were made within the last 3000 milliseconds. Hence the answer is 3. But the moment another ping comes at the millisecond 3002, now if you say that how many requests have been made in the past 3000 milliseconds, you will not count this one, right? Because this one is now older than the previous 3000 milliseconds. So you can only count 100, 3001 and 3002. That's why the answer is 3. So that is the problem statement, guys. That's how we have to calculate the past 3000 millisecond request and return in the ping method, and also add the new request, right? The constraints are that the value of t ranges from 1 to 10 to the power 9, and obviously each and every ping method will have a t value that is strictly increasing. At most 10 to the power 4 calls can be made to ping. Okay, now that we are clear with this, let's jump to the solution part. So the way to solve this problem is, guys, is to use a queue, because you can see that it is clearly we are adding the elements in a certain order, and then we have to basically not include the elements in our result set once they are more than 3000 milliseconds old. So in this case, you can see this was my queue, and I didn't include the first element. So basically I discarded this and then I included all the last element, right? So this is a data structure of queue, because queue is first in first out, right? When an element is first entered into the queue, it is the first element to actually taken off from the queue. So that's why in this ordered sequence of time, we are going to only consider the elements which were entered in the past 3000 milliseconds, and the elements which were older than that, just like in a queue fashion, we are going to discard it, right? So let's, as we know how we are going to implement it, let's jump to the implementation part. So the first thing is we have to implement the constructor, right? The constructor needs something to initialize. So I'm going to create a variable called as request. So this is going to be queue and this is going to be an integer queue. So integer, and I'm going to name it as request. Now this request is going to be initialized in this constructor. So this dot request equals to new linked list, which is, you know, an implementation of queue, and that's done. That's our constructor. Now let's jump to the ping function, right? So the first thing is that once we get a request, we add it to our queue. So this dot request dot add t, simple. Now we have to discard all the requests which are made previous to the last 3000 to the 3000 milliseconds. So previously we just have to discard all those. So what we are going to do, we're just going to put a loop, take the current time and keep subtracting the time of the queue elements if they are more than 3000 milliseconds old. So t minus this dot request dot element. So element function is a function of queue class, which basically gives you the first element in the queue. So if the first element in the queue is more than 3000 milliseconds old, that means the difference is more than 3000, we are going to discard it, and the discard method or the remove method is simply called as remove. So this remove method is going to remove the first element in the queue, and we will keep on removing these elements until your queue only contains the elements within the last 3000 milliseconds. And finally we are just going to return the size of the queue. So return this dot request dot size, and that's it. Now we are going to run this, and let's see it works for our example cases, and there you go, it does work for our example cases, and hopefully it will get submitted as well. And yes, it did. Now the thing is, guys, that we have to understand what is the time complexity and the space complexity of this solution. So let's see that. So first of all, let's see the time complexity. Now here you can see that we are running a while loop on every ping function, but have a look at this, that this while loop only runs until you remove the elements which are less than 3000 milliseconds, right? So whichever is minimum, if the element size is minimum or if the 3000 millisecond is minimum. So this is going to be the time complexity, because basically what you can say that the maximum time complexity is the value of the t elements n minus 3000, right? So if we have got elements which are, if we have got 10 elements and 5 of them are older than 3000 milliseconds, so the total number of elements minus the elements which are older than 3000 milliseconds, those are the that will be the times this for loop is going to run. So I would say n minus the elements which are older than 3000 milliseconds, so that will become your time complexity. Let's say the space complexity. So actually, guys, space complexity is also going to be the same. Why? Because at one point in time, our queue only contains the elements which are within the 3000 milliseconds range. So again, it's going to be the total number of elements minus the elements which are older than 3000 milliseconds. Okay. I know I have not written it bit correctly, like bit clarity wise, but I hope you guys understand the meaning that n minus 3000 basically means n minus the elements which are more than 3000 milliseconds old. So this is the number of times this loop is going to run, and this is the number of times this queue is going to hold the element. Okay. Now, the queue is going to hold the elements for the elements which are under the range of 3000. Okay, or I can say whichever is minimum, right? So the number of elements in the range of 3000, that will become your space complexity, and time complexity is the number of elements which are outside the range of 3000. Okay, let me do it like this: of elements outside the range of 3000. Okay, so in a big O notation you can still say that this is a linear time complexity and a linear space complexity. Okay, but that is a good way to solve this problem, guys. I hope you guys like this solution and your coding practice became a little bit better with this. If you have other solutions to this particular problem, guys, please do write down in the comment section below. I would be really happy to read them and learn from it, and others can also actually learn from that. So that would be really beneficial. If you have not yet subscribed to my channel, guys, then please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I had a target of hitting 1000 subscribers in 2022. Unfortunately, it didn't come true, but I'm so grateful for all of you who have been watching my videos and those who have subscribed to my channel, and for all of your, I'm really grateful for your comments and feedback. So for those who are still new to my channel, I would really request that please do subscribe, do like this video and share this video with your friends. Thank you so much for watching, guys. This will be the last video for 2022. So I hope you guys have a really happy new year and happy holidays as well. Thank you so much. I'll see you guys in the next year. Now take care and bye bye.